looking up at the night sky, where you see the horizon stretching into the unknown. Now picture this sight as a symbol of infinity. Today I'm going to discover with you the history of this fascinating term, the way it is used in mathematics and the modern era, and why it's left mathematicians, philosophers, and astronomers puzzled for decades. I can assure you, after this speech, you will be unable to look at infinity the same way without thinking about its possibilities on humanity. Firstly, to those of you who don't know what infinity is a number greater than any assignable quantity or countable number. Infinity is commonly known as the biggest number and is represented by this symbol. When people say infinity, they usually mean never-ending lengths or uncountable possibilities. While this makes you think infinity is a number, it isn't one. This is because in any real number, this equation must be true. X plus 1 is greater than x. With the number infinity, this is not the case. For example, 1 plus 1 is greater than 1, and 2 plus 1 is greater than 2. Even negative numbers work. Negative 26 plus 1 is greater than negative 26. However, infinity plus 1 is not greater than infinity. That being the case, infinity cannot be a number, because infinity plus a little more is still infinity. So, this fascinating term is not a number. So then what's it all about? How was it created? And why do people think it's a number? Well, the first reference to infinity was in 610 BC, when a Greek philosopher named Anaximander used the word aberon, which means unbounded or indefinite and could be translated to infinity. Another advance in the development of infinity was the symbol for infinity called lemon state. This was created by John Wallis, an English clergyman and mathematician, in 1655. Its meaning is supposed to be a never-ending path, which signifies infinity perfectly. You may be wondering how the word infinity came to be, like we do with most words. Well, it derived from the Latin words infinitas, which means unboundedness. Infinitas is made up of the Latin words in, not, and finis, which is the end or finish. Yet, these are not the only breakthroughs in infinity. Later, a Greek philosopher named Zeno of Elea, in 450 BC, tried to show how infinity was impossible by showing how to divide things infinitely. He stated the arrow paradox, which would be expanded upon and solved in later years by mathematicians. According to him, an arrow should never be able to hit its target. This is because you can divide the distance that the arrow has to travel by 2 infinitely. For example, if this is the starting point of the arrow, and this is the ending point, you can divide the distance that the arrow has to travel by 2, then by 4, then by 8, and so on until 1 over infinity. And since an arrow cannot travel an infinite length, it thus cannot hit its target. Another paradox Zeno mentioned was the Achilles paradox, which is a paradox that mathematicians are still working on today. Enough math, enough history. How is infinity used in math? It is used in many ways and is most known through calculus and algebra. An essential use for infinity is in differential calculus, where infinity is used constantly. For example, it is used when a line is nearly 0 but just not quite hitting it, which is 1 over infinity. This similarly also brings up the term negative infinity, where the numbers go infinitely toward the negative side. For example, in differential calculus, negative infinity is used when a line nears the end of a graph infinitely toward the negative side and never stops. As weird as it sounds, on top of negative and positive infinity, there are also different types of infinity. For example, there are countable and uncountable infinities. If you were to count all of the counting numbers, there would be a count to the infinite amount of them, since they are countable. What this means is that even though you will keep counting forever, there is a next number that is pretty simple. 1 goes to 2, 2 goes to 3, 3 goes to 4, and so on. However, uncountable infinity, an example, would be the number of divisions between 0 and 1. Since, even though you start at 0, what's next? 0.1? No. 0.01? No. 0.0001. There is never a set number that is next. Another example of uncountable infinity is the number of digits in pi, or the square root of 2, as we can't count that either. In fact, there are infinite types of infinity. So much for the biggest number. Now, a big part of infinity is obviously paradoxes. One fascinating paradox is that 1 equals 0. Now, what does this mean? For this paradox, we must use algebra. I know, boring, but it's actually pretty cool. If infinity plus 1 equals infinity, then we can take away infinity from both sides, meaning 1 equals 0. How do I know that infinity plus 1 equals infinity? Because, as I stated before, infinity plus a little more is still infinity. Now, if infinity plus infinity equals infinity, then we can take away infinity from both sides, meaning infinity equals 0. This statement brings us to a confusing shape, the circle. Imagine you had a triangle as a wheel. That would be painful, going up and down on the street. Now imagine you had 8 corners. That would be a bit better. Now imagine you had infinite corners. Well, infinite corners would be a circle, meaning that infinite corners is the same as no corners. I wonder what that sounds like. Now, you may be wondering how we count infinity. Well, to do that, we use sets. But what are sets? Sets are literally sets of numbers, shapes, or pretty much anything. For example, if we have a set with the numbers 1, 2, and 3 and a set of shapes, you can equally match up one number to a shape. This is how we count infinity. A better example is if you listed all of the counting numbers and all of the even numbers, you could equally match up each counting number to an even number. A fun fact that we just proved is that there are the same amount of counting numbers as even numbers. Infinite. Now, why am I telling you about sets? This is because at one point in your life, you will always have this exact argument. I'm smarter than you. No, I'm smarter than you. I'm 2 times smarter than you. Well, I'm 10 times smarter than you. Well, I'm 100 times smarter than you. Well, I'm infinite times smarter than you. And the next person always says, without fail, I'm infinity plus 1 time smarter than you. But that's wrong, because we already proved that infinity plus 1 equals infinity. So how do you say that you're smarter? Well, before we can talk about that, let's quickly go back to sets of numbers. Let's say we have a set with the numbers 1 and 2. We're going to see how many subsets we can make from that set. So from just those 2 numbers, we can make the subset 1, 2 with both the numbers in it, 1 with just 1 in it, 2 with just 2 in it, and an empty set. With the numbers 1, 2, and 3, you can make 8 subsets as listed here. Now, if x represents the amount of numbers in the original set, 2 to the x represents the amount of subsets that can be made from that set. So for example, if there are 3 numbers in a set, for example 1, 2, and 3, you can make 8 subsets as listed here. Now, the number of subsets, or 2 to the x, will always be greater than the number of values in the original set. Now, what happens if I have a set with infinite numbers? All of the counting numbers. Well then, the number of subsets would be 2 to the infinity. And as we just proved, 2 to the infinity is greater than infinity. So, as you can assume, the next sentence will be, I'm 2 to the infinity times smarter than you. Unless your opponent is really smart and says, well, I'm 2 to the infinity times smarter than you. And in that case, you guys can keep arguing forever, because there's always something higher than x, 2 to the x. Now, A very interesting paradox from the documentary Trip to Infinity is a paradox that I like to call the anything box. Now imagine you have a box and you place a cucumber in it. This box is an amazing box. Nothing can come in and nothing can come out. Now we come back in a month, the cucumbers are kind of decayed. We come back in a year, the cucumbers are real nice. Actually, you don't understand the cucumbers work. Come back in 100 years, the cucumber is some kind of fine dust. The cucumber contains chemical energy, the same kind of energy you get if you eat the cucumber or burn the cucumber. That energy will eventually come out, and so the cucumber dust in the box will start to get very hot, probably thousands of degrees, and nuclear reactions will start to happen. Now, this will take a long time, since nuclear reactions happen incredibly slowly over millions of years, but eventually it will happen. Basically, your cucumber has turned into millions of degree plasma of fundamental particles. Eventually, after lots of nuclear fusion, you'll probably end up with some type of iron nuclei and lots of photons. Billions and billions of years later, neutrons will become protons and various other particles. And then it will sit there for a very, very long time. Now, if there are 10 to the 24 particles in a cucumber, there are something like 10 to the 10 to the 24 states that the particles of those cucumber can be. That's an enormous number, but it's not infinite. And what that means is that if you let the box sit there for an absurdly long amount of time, it will use up all of those 10 to the 10 to the 24 different states. And so, it will start having to reuse things. And this is the power that infinity has over finite. Eventually, when you come back and you open the box, there is your nice fresh cucumber again. In fact, anything that can exist in that box will exist. Whether it's a time machine or a black hole, everything that can be there will be there. And they will each exist an infinite number of times. The thing that keeps me thinking is that we might be in the box. By the way, you might not want to eat that cucumber. Now, you may be thinking, well, why is infinity so interesting? We've already done all the calculations we need with it. Well, there are a lot of uses for infinity in the modern era. These include, but are not limited to, cosmology and astronomy. One amazingly useful use for infinity is the infinite universe or multiverse theory. The multiverse theory is that there are infinite, finite universes existing alongside each other, but we can't get to any other universe in any way. Now, if any of you have ever seen Doctor Strange and the Multiverse of Madness, you know exactly what we're talking about. The infinite universe is that the universe just expands on infinitely with infinite possibilities. So, as you can probably assume by now, infinity does not really follow math. So, for example, as I stated before, 1 equals 0 and infinity equals 0. This does not make sense in modern mathematics. This is because infinity breaks all the rules of math. From simple addition to complex calculus, infinity never follows the mathematical principles we've learned since kindergarten. That being said, infinity is one of the most out-of-the-box terms we've ever discovered. And I think infinity made the right choice, because I wouldn't want to be in the box without a cucumber. So, even though we reference infinity in so many ways, like to infinity and beyond, the infinity gauntlet, the infinity stones, and even pi, we never take into account the thrilling properties of this bewildering term. Take pi, for example, a never-ending term. But what does a never-ending term actually mean? So pi, the radius of the circumference of a circle to its diameter. And this is just the beginning. It keeps on going forever without ever repeating. And what that means is that contained within this string of decimals is every single other number in every format. Your birthday, the combination to your phone, your social insurance number, all within this one symbol. And if you convert these decimals into letters, there will be every word that ever existed in every possible format. The first syllable you said as a baby, the name of your latest crush, your entire life story from beginning to end, everything that we ever say or do, all of the world's infinite possibilities rest within this one simple circle. Now, when you choose to use that information, what it's good for, well, that will be up to you. In conclusion, infinity has a lot of uses in modern mathematics, and many mathematicians are confused by even the idea of infinity. Infinity is still used today and is a very interesting topic, in my opinion. I hope you walk away from here feeling a lot more knowledgeable and maybe even interested in learning more about infinity. After all, infinity is a lot bigger than